Okay, let's get this show on the road. So, hi everyone. First, I hope you all have been having an amazing Ignite. Who's learned an amazing amount of stuff this week? Yes. So, show of hands, who is already at the stage where they're like, man, I have learned so much, I can't keep any of this in my brain? Well, do me a favor, just take a deep breath and try and make a little bit more space because we're going to be talking about a bunch of stuff. I have 45 minutes, and I am going to just be running through a whole bunch of information. So hopefully you'll retain this. Right at the end, I do actually have a QR slide with a QR code with a link to this deck online so that you can grab it and get all the information yourself. With that out of the way, hello. Hopefully many of you know who I am, but for those of you who don't, I am Benjamin Armstrong, Principal Program Manager working on the Hyper-V team, and I am here today to talk about the Hyper-V roadmap. So why am I doing that? This is not a very Microsoft thing. We normally don't talk about roadmaps. And the reason why is because that's what everyone has been asking me about over the last year or two. I've spent a lot of time going out and talking with customers, and the most common question I get is I have people coming to me and saying like, hey, we're using Hyper-V, we love Hyper-V, it's great, but can you let us know where it's going? What's happening in the future? What's coming next? And so today, I'm going to spend some time just going through and talking about all the stuff my team's been working on, all the stuff we've been delivering and areas we've been focusing on, and then I'm going to be pointing out, okay, these are kind of the areas we're going to be investing in, and these are the sorts of things that you can expect to see coming out in future releases of Windows Server and Windows Desktop. So with that, let's get going. So the first obvious thing to talk about is Azure. Azure is my largest cloud customer. And I do want to highlight that when we run Azure, they are running on exactly the same version of Windows and Hyper-V that you get. You know, this has been one of my big conversations this week. As I'm chatting with people, I've had many people come up to the booth and say, is that really true? Like, surely there's some differentiation. No. It's exactly the same version of Hyper-V that we run in Azure, that we put in Windows Server, that we put in Windows 10 running on your laptops. Same code. So what have we been doing over the last year for Azure? Well, the first thing we've been doing is we've been really focusing in on quality. And this has actually been a fascinating experience. You know, we've had a number of engineers on the team where pretty much their only job has been to gather information about what's happening inside Azure and to start drill in and to try and find out, how reliably are virtual machines starting? Sometimes they take longer than we expected. What about live migration? What about all the different operations? And they've been drilling in and trying to figure out how to make this as reliable and as consistent. And it's great because we have data across like hundreds of thousands of operations a day. And so there are issues that we've found where it's like, yeah, this only happens one time in 20,000, which means we see it 5 times a day in Azure, which gives us an opportunity to dig in and just continue to refine the platform. Building on that, we've also spent a lot of time working on making performance predictable. And what I mean by this is when we are selling virtual machines in Azure, we want to be able to guarantee to customers that, hey, if you come to Azure and you buy a set of virtual machines to run your workload and you run them today and it runs great, that it will run exactly the same way tomorrow and in 3 weeks' time, no matter what else is happening on those computers. We've also been spending a lot of time working on low-impact servicing technologies. And this is a session in and of itself. I have a QR code there that you can grab a snap of, which actually goes to a lot of our online documentation. But we have been doing so much around using live migration in different ways in Azure, and using hot patching, and building all different types of servicing technologies so that people can run their workloads on Azure and not be affected when we have to do updates, when we have to deal with hardware issues. But so moving on, the fun bit for me is actually when I look at what are the new compute technologies that the Hyper-V team has delivered to Azure over the last year. So the first one I want to talk about is the MV2 series. And that is a link to actually a demo video that we have. These are the world's largest virtual machines that you can get in the public cloud today. 416 virtual CPUs, 12 terabyte of memory, and we will drain your credit card in 3 seconds if you try and run one. Seriously, I would strongly recommend that no one in this room try this out. Certainly, you don't have enough credits on like your free MSDN subscription. So I do have people ask, okay, they see the price tag on it and they're like, Ben, why on earth are you guys doing this? Who would ever pay that amount of money? And the answer is that we have customers who are running high-end SAP and high-end SQL workloads where they need that sort of compute capacity for 2 weeks of the year. For the rest of the time, they just need a big VM. And if they were doing this on premises, they would have to pay for the sort of hardware that would deliver that workload for the whole year. And that hardware is insanely expensive, and for most of the year it would sit there underutilized. Whereas with Azure, they can run their servers at an appropriate scale for 95% of the year, and when crunch time comes, they can shut them down, size them up to an MV2, and then spend 2 weeks running at massive scale to get the results that they need. So the next one we have is the HB V2 series. And I love this. So HB, the whole H series, we have HB, HC. These are our high performance compute cluster series. And this is for people who are doing massive scale out operations. And we were actually here last year talking about updates that we'd done to the H series, and we were standing on stage and going like, we can now do a scale out compute cluster in Azure of 10,000 nodes. Well, here and now today, just in the last 12 years, we have increased that scale by 8. We can now do a scale-out cluster of 80,000 compute nodes for massively parallel operation. Now, what has enabled this has actually been our extensive investments in networking technologies. We've been lowering the latency, raising the bandwidth and throughput so that we can start to scale up and we can still keep track of these parallel operations. This has been, if you've been following the news, Azure has been deploying a lot of the Mellanox hardware that many of you guys have been using in your own deployments in order to get access to RDMA and other low latency technologies. So that's really exciting to see come along. Then we have the NV4 series, NVV4. This is another one that I love because it just shows how quickly we are innovating in Azure right now. When we were here last year, we were talking about the NVV2. We've actually done 2 whole generations. NVV4 has just come out into preview. The NV series are our GPU-enabled virtual machines. And in the case of NVV4, we're using a technology that we call GPU partitioning. Now, if you're familiar with what we have today when it comes to GPU and virtual machines, we basically have 2 offerings. The first one is we have a remote effects style offering where what we're doing is we're providing a fake GPU for the virtual machine. Now, the nice thing about that is it's really scalable, it's really flexible, but it delivers nowhere near the performance of an actual GPU. And you can't access, the specific unique characteristics of the GPU you're running. At the other end of the scale, we have discrete device assignment, where you can take a GPU, you can assign it to a virtual machine. And that's great because you get all the access, but it's terrible because last time I checked, most people like to run more than one virtual machine on a server. And when you do a discrete device assignment, 1 GPU to the virtual machine. So GPU partitioning is where we actually carve up a GPU, and we still expose the real GPU through to the virtual machine, but it's no longer this one-to-one relationship. And I'll talk a bit more about that later in the presentation. The final thing I have to talk about is the LSV2 series. We actually talked about this last year at Ignite, but it wasn't available then. It has now gone into production. And the LS series is our storage optimized series of virtual machines. And for people who are using Windows Server 2016, Windows Server 2019, and really care about high storage performance, you know about, you can take a discrete device assignment, you can pass an NVMe device or a storage device through a virtual machine to get the highest possible performance. Well, with the LSV2 series, we took discrete device assignment, and we made a number of improvements specifically focused at giving the highest throughput, lowest latency, lowest overhead experience for passing through NVMe devices. And we built a technology that we call NVMe Direct. And we now have LSV2 virtual machines available in Azure, where a single virtual machine is able to drive 3.6 million IOPS, all running on top of Hyper-V. Now, before moving on, one thing to call out is that a number of these new offerings have actually been a result of our partnership with AMD and working closely with their EPYC architecture, getting it deployed in Azure and lighting up these ultra-high performance, ultra-high scale environments. And the last thing I want to call out before I wrap up on the Azure section is there is one thing that we've done this year which I'm super excited about. I know that many of you have been bugging me for years and saying, why can't you guys get this organized? Short version, it was a lot harder than we all thought it would be. But we have Generation 2 virtual machines coming to Azure. So this is currently in preview. I don't know the specific GA date. It is getting very close. But I would like to show you a quick demo of Generation 2 virtual machines in Azure. Now, because time is tight, I am using recorded demos today. I apologize. I usually do them live. But with 45 minutes, I didn't want to risk a misclick. But in this demo, I've just logged into the Azure portal. This is using my account where I am, surprisingly, a Generation 2 VM preview customer. And first, I'm just going to go through the standard UI and provision a Windows Server virtual machine. And what you're going to see is I'm going to fill out the details here. And towards the end, you'll see that there'll be an option to select Generation 2 virtual machines. Now, this is actually really important for a number of reasons. The first one, obviously, is many of you have Generation 2 virtual machines in your infrastructure, and you want to be able to easily move them up and down into Azure. Well, this enables that. But the second thing is that a number of the high-scale goals that we've been talking about actually have required us to get Generation 2 virtual machines running. So the MV2 virtual machines that I discussed, 12 terabyte of memory. Guess what? You need Generation 2 virtual machines to be able to do that. Another big one, which I've actually been talking to a couple of people this week about, is that Generation 2 virtual machines can have really large system drives. So we're now at the stage, I've got to the advanced, and we now have a generation button. And I can go in and say, I want this to be a Generation 2 virtual machine, and it will go ahead and create it. Now, once this goes through, I'm actually going to run the UI just to creation, and then I'm going to do the TV cooking show trick where I'm like, okay, let's show you one that we've prepared earlier so we don't have to sit here and go through the whole provisioning process. So this is a Generation 2 virtual machine that I've already configured, and I'm going to connect to it using RDP just to jump inside and show that, hey, this really is a Generation 2 virtual machine. I'm going to pull up two things. The first one is a bit lame, but it's the easiest way to tell if you're in a Gen 1 or a Gen 2 virtual machine. Generation 2 virtual machines don't have a floppy drive. If you go here on a Gen 1 virtual machine, there'd be a floppy drive. The second thing is to just pull up sysinfo, and you can see that this is a UEFI-based virtual machine. So this is a Generation 2 virtual machine that I have running on Azure. So that kind of brings a wrap to what we've been doing over the last year for Azure, which then leads naturally into Azure Stack. Azure Stack Hub, Azure Stack Edge, Azure Stack HCI. So to just kind of set the stage here, one of the things this week I've had a lot of people coming to me and saying, hey, why is Hyper-V better than every other platform out there? Why should we be using Azure over AWS? Why should we be using Hyper-V over VMware? And my answer has always been, we are the only true hybrid offering out today. We are the only company that builds a hypervisor, builds a virtualization solution, builds an operating system that we run at public cloud scale, and we then give exactly those same bits to you. And there are so many benefits from that. But what's happened over the last year? First one, which I'm super happy about, we've rolled out the update to the Azure Stack family line that's now all running on Windows Server 2019. We've also been spending a lot of time building up our guidance around when should you be using Azure Stack Hub, when you should be using Azure Stack Edge, and when you should be using Azure Stack HCI. On top of that, and this has been another conversation that I've been having a lot of this week, is I've had a lot of people coming to me and saying, hey, okay, we're all in. We want to deploy Azure Stack HCI. We want to migrate from all our old platforms to Azure Stack HCI. How do we do it the right way? And my answer has always been, well, the wrong way is to go dig around in the dumpster bin in your data center, find some spare computers, throw something together, and think that this is going to be a great platform. You would be surprised how many times I run into customers who've done that. They're like, we're going to build our next virtualization platform, and the way we're going to do it is by finding whatever hardware is free in our data center and hooking it up. That is never a great solution. And so what I tell people is, what you want to do is you want to go out to a trusted partner, to a trusted OEM, and you want to go to them and say, okay, we're doing a new Azure Stack HCI deployment. Give me the hardware that I need. And so over the last year, we've been working with the ecosystem and with our partners, and we currently have over 154 validated hardware offerings from all the different partners. So I can pretty much guarantee that if you go to your partner and say, I want to do Azure Stack HCI, they're going to come back and go, okay, here are the solutions that are available to you. So what have we been doing for Hyper-V in Azure Stack HCI? Well, the first thing to call out is that much like Azure, we've been spending a lot of time focusing on quality. We actually have a team that meets every other week, goes over all the open customer support cases, and looks into what the root cause is. I will say, hint, 90% of the time, it is storage or networking misconfiguration. But we're then working with our hardware partners to get issues addressed. We're working to get documentation and guidance improved. We're working to provide training. We're identifying fixes, but quality is a big focus. The next thing that we've been doing is working really closely with the Windows Admin Center team. Who here is really excited about all the announcements we've had around Windows Admin Center this week? Yeah. I'm really happy. I don't know if people caught this or not. We've had an update come out at this event, and one of the things we've added is support for our live migration with Hyper-V through Windows Admin Center. So if you're managing Hyper-V, you can live migrate between standalone nodes, inside a cluster, in and out of clusters, all the live migration options. We really want to get to a world where Windows Admin Center is a complete replacement for Hyper-V Manager. And already it has a number of things that I always wanted to do in Hyper-V Manager that we weren't able to do. My favorite one is that you can finally group virtual machines in the UI. That is one of the ones that we wanted to do forever. But the final thing to call out before wrapping up on this section is the other thing that we're doing is bringing innovations across from Azure. This is a key thing to understand. You know, when we talk about hybrid cloud, the model that we're now in is that the Hyper-V team is constantly building features and capabilities for Azure. We're rolling them out to Azure on a very rapid cadence. But then, in the next release of Windows Server, all of that gets rolled up and made available to all you all to run in your data centers. So if you think about what I've talked about so far, and you think about the MV2 series, it makes you go like, I wonder what the scale limits are going to be for virtual machines in the next version of Windows Server. Something tells me maybe 416 vCPUs, maybe 12 terabyte memory. I don't know where I'm getting that from, but just kind of an intuition. And I wonder in the next version of Windows Server how we're going to be telling people to configure high-performance storage. Maybe something called NVMe Direct, just an idea. And in fact, if you really want to know what's coming in the next version of Windows Server, we have a release blog for Azure that just every time we pull up something out for Azure, it gets put there. You can go there, filter it to compute. Just keep an eye on that. Like that is the inside game for what's coming next. with that in mind, I'm going to switch across to what I think is one of the funnest demos I have today. And this is a demo of running virtual machines using GPU partitioning on just standalone Hyper-V server. So this is something that we are working on furiously today. Now this was just set up using Hyper-V PowerShell, no complicated management. I have to get the number right, I have it written down here, otherwise I'll get in trouble. This is a Dell PowerEdge R740 that was provided to me. Thank you, Shai. And it's running the Radeon MI25 adapter. And on this one, I have the Radeon carved up into 4 chunks. And you can see I have 4 virtual machines that each see a Radeon MI25 adapter. And they have full access to that. Now I'm going to go ahead and I'm going to fire up actually a fairly intensive benchmark inside of all of these virtual machines. It's going to come up, and after it fires up, you're going to see that it gets around 20 frames per second in each of these virtual machines. Now, unfortunately, with the limited time, I can't spend a lot of time showing all the options, but one of the things I really like here is we can actually go in and we can configure how much we carve up the GPU, and the frames per second that you get actually scale pretty linearly. If I say just 1 GPU chunk to 1 virtual machine, it gets around 80 frames per second. If I say 2 GPU chunks, 2 virtual machines, they each get around 40. I can do 4 to 4, and they each get around 20. I can do 8 to 8, and they each get around 10. So it's very flexible, very scalable, allows you to start building solutions where you say, okay, I'm going to have a nice high-end server. I'm going to put 2 GPUs in it, and I'm then going to provide accelerated 3D graphics to my users who need that, but run it at a cost-effective scale while not compromising on performance or capabilities. So really excited to see that coming along. So, thank you. So we've talked about Azure. We've talked about Azure Stack. What's the next big area of focus for us? Well, it's security. Hyper-V has become foundational to our security platform, but at the same time, the security landscape of the world is just getting harder and harder. So I can't talk about security without first talking about Specter and Meltdown. So I would encourage, if you're really interested in this, please follow that link. That actually goes to a blog post where we talk at length about all the efforts that we've been doing to mitigate the Specter and Meltdown attacks. And this is an ongoing area of investment for us. Most people don't get up on stage and say this because it is unpleasant to say, but the 2 things to be aware of is Specter and Meltdown really just opened the Pandora's box for alerting security researchers to the fact that, like, hey, there's a new way to attack the platform. And so people are still looking at that, and they're still finding ways. The second thing to point out is you'll notice that the language that people use when they talk about Specter and Meltdown, they use the word mitigation. What does that mean? That means it's still there. These are really hard architectural challenges, and what the entire industry is doing is we're working on hardening our platforms to try and make these problems harder to exploit. But the underlying problem is still there. So in that vein, one of the things that we've also made available for this is a capability called CPU groups. And what CPU groups allow you to do is, because the underlying problems are still there, and because while we have mitigations, the problem is still there, we're now providing the ability for you to go in and configure Hyper-V and to be able to say, you know what? I have like 3 different workloads on this server with different security characteristics. I want to set up groups of CPUs and keep those virtual machines separated. I want to take my potentially untrusted virtual machines and keep them just on entirely different processors than on my high trust virtual machines. So that's something that we allow you to do. But going on with the evolving security landscape, another thing that we've been doing is, one, we've been staffing up our own security team. We've been spending a lot more time doing both code analysis, but doing active attack against Hyper-V ourselves. we've also been engaging with the security community to say, hey, come and help us. So what have we done for this? The first thing we've done is we have launched a Hyper-V bug bounty. We've been going out to the security industry and we've been saying, hey, come try and find problems in Hyper-V, and if you do, and if they're valid security issues, we will pay you. Beyond that, we've actually been doing everything we can to make it easier for external security researchers to conduct this activity. One of the big things is we're now providing all the symbols for Hyper-V. This makes it a lot easier to debug and understand what's going on. And why are we doing this? Because as I said, the security landscape is just getting harder and harder out there. We know that people are trying to figure out how to break Hyper-V, and we would rather have them on our side and telling us when they find information. Now, lightening things up a bit, let me pivot over now to talk about some of the security functionality and capabilities. And the first thing I want to talk about is actually one of my personal favorite uses of Hyper-V that very few people know about from a security landscape. How many people here use Office 365? How many people here have ever been sent an email with a virus attached to it? No, never happens. So, as you can imagine, we have millions of attachments going through Office 365. Every day. And as you can imagine, it is in our best interest to not have customers get viruses. And so we do some analysis of the attachments. We do basic virus scans and so on. And as you can also imagine, people do tend to forward things on. So, we can look at checksums and so on and be like, oh, we've seen this file before. It's all good. But even with that in place, every day in Office 365, we see hundreds of thousands of attachments which we've never seen before. We've never seen the checksum for it. We don't know if it's safe. So what do we do? Well, what we actually do is we have a team, the Office 365 Advanced Threat Protection, and as part of their analysis, whenever they see an attachment that they've never seen before, they have an entire engine where they rapidly spin up a virtual machine. They open that attachment in the virtual machine, then they freeze the virtual machine, and they check to see, did any of the system files just get modified? Because reasonably, no, they shouldn't. That shouldn't happen. If they see any of the system files modified, they go, okay, we're not sending this attachment on. Something is up here. Otherwise, they send it on. But they are doing this 100,000 times a day. They're creating a virtual machine, trying it out, looking at the results, and sending it all in an automated forensics way. So I think that is just a fascinating use. Now, of course, hopefully, show of hands, you all know about shielded virtual machines, please. Thank you, that's good. If you don't know about shielded virtual machines, please come down to the Hyper-V booth and we will happily tell you about this amazing technology. Shielded virtual machines is our leading security technology for private cloud environments. We are continuing to invest in this. Over the last year, we've been making minor improvements to the usability, but we are actively working inside Azure today to continue to raise the bar for providing secure virtual machines where you can have your secrets, have confidential information, and have it be trusted. I can't go into much detail on this today, but I can say this is an area where, stay tuned. There's going to be improvements and new features here in the future. So after shielded virtual machines, we have Windows Defender Application Guard. How many people here have tried out Windows Defender Application Guard? Not enough hands. So Windows Defender Application Guard is another virtualization technology that is available on Windows 10 desktop. And this is where in an enterprise, you can configure it so that you have a set of trusted websites. And if one of your users goes to a website that's not on that list, what the user sees is they see a little window pop up and say, just a moment, we're installing Windows Defender Application Guard. And 2 seconds later, they're dropped in a new Edge window that they can browse in. On the back end, we just rapidly spun up an entire new virtual machine running an isolated version of Windows 10, started up Edge in it. They can browse it. They can do whatever they want. And when they close that Edge window, we throw away that virtual machine. And this all happens in a couple of seconds. But You all should be using this yourself. I use it myself. You don't need to be in an enterprise for it, because how many people here have had that moment where you're just browsing the web and maybe you're looking for some tool to download and you see a link and you're about to click on it and like the spidey sense tingles and you're like, this might not be a good idea. Anyone have that? Yeah. And come on, let's be honest. How many times have we gone, click on it? And then you're like, and you go to the website and it's full of all the spam and you're like, close. So you can enable Windows Defender Application Guard on any installation of Windows 10 Professional or Enterprise. It's been there since 1809, so the release last year. And once you've got it enabled, you can actually, when you have that moment, just go up to the menu, and right next to where there would be Launch and in Private window, there's Launch Application Guard window. You go, okay, Launch Application Guard window, and once again, we rapidly spin up a virtual machine. You get a new browser, and then you can go to that questionable site and be like, see if it's okay or not, and if you have the panic close it, we blow away the virtual machine. And it's a great tool. Now, we've been working on this over the last year. We've added support for plugins for Chrome and Firefox, so enterprises that have users who are using those browsers can still have this trusted site capability. We have also announced at Ignite this year that we're working to extend Application Guard to support applications other than just Edge. We actually had a demo earlier this week of running Office inside of Application Guard, so that when people open attachments that may be questionable, you can have this disposable virtual machine again. Another thing that we've done over the last year is we've introduced Windows Sandbox. We actually have a session later today where we're going to be going into detail on Windows Sandbox, but Windows Sandbox basically takes the underpinnings of Application Guard, and rather than tying it to a specific application, we just give you a disposable instance of Windows 10 running inside a virtual machine that spins up quickly, that you can try something with, and you can throw it away. Now, pulling all this together, one of the other announcements that we had just in the lead up to Ignite, which I'm super excited about, is the secured core PC. Now, over the last 4 or 5 years, we have rolled out security technology after security technology that's based on virtualization. We have VBS, our virtualization-based security. We have Credential Guard. We have Device Guard. We have Hypervisor Enforced Code Integrity. We have a long list of security technologies. The problem that we have had is that, on one hand, from Microsoft's point of view, we have been dying to just turn on all these technologies by default. Like, we want everyone running as many of these as possible, because we don't like it when our customers get hacked or get viruses or so on. That's not fun for anyone. So we want all these technologies on. On the other hand, we have been receiving feedback from customers when they're like, hey, when I turn all these technologies on, I have this old device driver that stopped working because it's doing something that it shouldn't really be doing. Or when I turn it on, I had a problem with this application or so on. And so we've been investing a lot of time trying to address those issues. But just 2 weeks ago, we announced Secure Core PC. And what this is we actually went out and we partnered with a number of our OEM partners, and we got them to build systems with images with all the security technology turned on by default, and do full validation on all the drivers, on all the devices, on all the power profiles. So if you do a quick web search for Secure Core PC right now, you will find the first hit will be the Microsoft site, where we will give you pointers to offerings from all the top OEMs, where they're now providing laptops and desktops which you can go and buy, which they have tested with all of these technologies turned on, and these technologies are enabled by default. So super excited about that. Thank you. Now, to close out the security section, and bringing to mind the whole idea that we want all of these technologies on by default, this has actually led to, honestly, one of the more fun and unexpected activities of my life of the last year, which is that this year I was on stage at VMworld. This is something I would never have seen coming. So as we've been working on these technologies, and as we've been talking to customers about get these turned on, one of the things that both VMware and Microsoft have been hearing is like, hey, I really want to use Device Guard and Credential Guard and all of these great technologies from Microsoft, but I also want to use VMware Workstation. And so a while ago, we reached out to VMware and said, hey, let's work together and figure out how to make this a thing. And we've been quietly working together for a while now. This year at VMworld, in one of the most confused audiences ever, when they were in the middle of the What's New in VMware Workstation, and they said, and now we'd like to invite Ben Armstrong from Microsoft to stage. They announced and they publicly demonstrated VMware Workstation running on top of the Hyper-V hypervisor. And they have also announced that they're planning to have that in beta early next year. So we're super excited to see that coming. So with that said, let me do a quick demo of Windows Sandbox. So this is just another feature you can enable. You click on it, and moments later, you have a new copy of Windows 10 running, and it is just a clean copy of Windows 10. Now, I wanted to show you how to break a copy of Windows and throw it away and regenerate it, and I wanted to do it easily and quickly for demo. So I did find a fun way. This doesn't break Windows, but good Lord, it breaks Explorer. What I'm doing is I open Command Prompt and change the desktop directory, and I X-copy everything from System32 onto the desktop. Now, the Windows kernel has no problems with this, and Command Prompt is a champ. It's doing its job. But Explorer is super unhappy. To highlight, this is going to copy just shy of 5,000 objects, many of which have strange ACLs and security properties, onto the desktop. And what you're going to see is, like, already the shell has gone unresponsive. It's going to crash, and so on. So this is now not a happy system. And the great thing is, though, is that this is a disposable system. So when this is done, I'm going to be able to throw it away. And as I said, we have a session talking in detail about this, because one of the amazing things about Windows Sandbox is I did not have to install a new copy of Windows 10 in order to use this. Instead, what we did, so here I am, I'm going to throw away the changes, say, okay, I've done a bad thing, and then I'm just going to start it up again, and you'll see a clean one. But what we actually do is we go, hey, we already have a copy of Windows 10 here. We just need to make a read-only reference to all the system files, and we can start up a clean version in an isolated virtual machine. So there we are. Nice and quick and easy. So that's security. Moving along, I am going to quickly touch on containers. Now, I'm going to touch on this quickly because we have a lot of sessions here on containers. Hopefully, you've been to some of them. We have a couple coming up this afternoon as well. But I am also going to touch on it because a lot of people forget that it's Hyper-V that enables this platform, and we actually do a lot of work to support it. So at a high level, some of the things that have happened in the last year that I'm really excited about. We've had Kubernetes support come out for Windows Server containers. That's somewhere you can expect to see us continuing to invest in. We've also started to get Azure solutions running on top of the Hyper-V container platform. I really like this one. We have the Azure Functions team, provides a platform where people can come and run Python scripts without having to have the entire environment. That's all running on top of Hyper-V containers. But bringing it closer to home, we've also been investing in improving Windows Server containers. Specifically, we've invested in decreasing the size while increasing the compatibility. Now, I was going to do a nice demo here, only I knew I'd be running out of time. So instead, I'm just going to go with a screenshot to talk about this. And I just want to step through what I actually have here is I'm running Docker, and I've got 4 copies of the server core image. The first 2 copies are the 1809 that we released this time last year, and the 1903 from the beginning of this year. And you can see their size on disk is around 4.8 gigabyte. The next two ones I have are actually insider images. The third one is the 1909 image that is just about to drop, and you will see that it's actually drastically smaller. It is about 3.6 gig in size. But the final one is really fun because that is the 20H1 insider image that we're working on right now. And you can see that it is currently at 2.64 gig, so almost half the size of the server core image that you have today. And unbelievably, it actually has higher application compatibility. So we're testing it and we're able to run more applications in it. So I'm looking at the time and I'm running out of time, so I'm going to have to go fast through this section. The final section I have to talk about before wrapping up and talking about roadmap is developers. We've been doing a huge amount of work to use virtualization technology to make Windows 10 a great place to be a developer. We've worked on the Windows subsystem for Linux, and now we're releasing V2. How many people here have used Windows subsystem for Linux? I like that. It should be all the hands, but I like that. Windows subsystem for Linux is something that the Hyper-V team owns the core engine of, and it's something we're immensely proud of. We've been obviously working on Docker for desktop. We also have a great relationship with Canonical, where they're building optimized Linux virtual machines. Who here has created an Ubuntu virtual machine from the Quick Create gallery? It's a great experience, but the thing I really love about it is that's actually an image that Canonical creates and provides for us to give the best experience for users. An esoteric one that I like to point out is, how many people here think the HoloLens is cool? Come on. Jeez. It's cool. How many people here are having fun developing on the HoloLens they have? Because we all have HoloLenses, right? Sad. Yes. To deal with this problem, the HoloLens team actually provide a HoloLens Emulator, which, guess what, runs on top of Hyper-V. This is actually really fun to play with. You don't have to be a developer to play with it. You can actually go to the HoloLens site and say, like, I'm a developer, where's the emulator? And just download it. It's like a 100 meg package. It runs on top of Hyper-V, and it gives you a completely emulated HoloLens environment. The final thing that we've done in this space is, know how I was talking about in security, we're targeting enterprises. People wanted to be able to use VMware, so we went and partnered with VMware. Well, in the developer space, we've had a lot of users being like, I love Docker on desktop, I love WSL, I love all this technology that you're doing, but I'm also an Android developer, and I use Google's Android development tools, and they have their own Android emulator that uses its own hypervisor, and that doesn't work with Hyper-V. So while we were busy going off and partnering with VMware, we were also partnering with Google, because, cats and dogs, get it? But a similar thing. We went with them and we said, like, hey, can we figure out how to make this work together? And we've had an engineering engagement going on with Google, and they've been updating the Android emulator to be able to run on top of the Hyper-V hypervisor. So now I'm going to quickly do a WSL2 demo. So one of the big differences between WSL1 and WSL2 is that with WSL1, we had an API translation layer that sat on top of the Windows kernel and exposed Linux kernel APIs up. With WSL2, we actually have basically a micro VM running a custom Linux kernel that is shipped by Microsoft. And this has drastic effects on both the performance and the compatibility. So in this demo, I have two windows. The top one is WSL2. The bottom one is WSL1. You can run these side by side. And side note, if you want to be able to tell which one you're in, just look at the kernel version. WSL1 returns a kernel version of 4.4. WSL2 returns a kernel version of 4.19. So my top one is WSL2. My bottom one is WSL1. So as I mentioned, one of the reasons why we did this, speed. So I'm going to npm install Redis, just stand up a basic install of the Redis database. I'm going to kick it off in WSL1. I'm going to kick it off in it's done. As you can see, and poor WSL1 is going to take a little while. Much faster, in fact, close to native performance. But on top of that, we also have much increased compatibility. One of my favorite things that you can do with WSL2 that you can't do with WSL1 is you can actually run Docker running Linux containers inside your WSL2 environment. So there you can see I just ran a basic Docker container that output that graphic. But we've had since we've released WSL2, we've had a huge number of people coming out and saying like, hey, look at just everything works. So I'm almost out of time, but we're in the final run. So let me take all of this and wrap it up with what is the roadmap. So the first thing, hopefully, obviously, is that hybrid cloud remains a huge amount of investment for us. You know, genuinely right now, when I look at the Hyper-V engineering team, like the majority of the team is working on hybrid cloud in one way or another. And the second thing, just to click down on this is, you know, for Microsoft, hybrid cloud is the destination. And the model that we're following for the Hyper-V team is we want to continue to build innovation. We're going to be shipping it to Azure, and then periodically we're going to be releasing Windows Server, which takes everything that we've been deploying and doing in Azure, wraps it up, and makes it available to the entire world. Like that is our model. And this remains a big focus for us. The next thing is security. We are certainly not done with security. I don't think we'll ever be done with security. But hypervisor and virtualization is becoming more and more important in providing strong security boundaries. And we have a large amount of people working on building more and more technology and new ways to solve problems. Then containers. Also, hopefully not a huge surprise. You know, this continues to be an area of investment for us. The final thing, which is actually kind of to me, this is the only interesting one, well, the only surprising one. Hopefully those first three, you're all sitting there going like, well, duh. The interesting thing that we do see happening right now is there's a lot of ecosystem innovation. There's a lot of conversation happening between the hardware and software partners where we're seeing technologies like GPU partitioning come out. We're seeing conversations going where hardware developers are looking at problems that we've been solving with software and going, hey, can we work together to do that better in hardware? And my expectation is that over the coming years, what we're actually going to see is we're going to see thinner and thinner virtual machines because we're going to have more and more virtualization capabilities in the underlying hardware. And virtual machine is going to be more about taking those capabilities, carving them up, and exposing them up, rather than the traditional emulation and virtualization that we've done. So with that, I am 2 minutes over. I would like to thank you all. That QR code is actually a link to this deck with all the video demos in it. I'm going to stay here and answer questions until they kick me out, but for people who need to go, you're free to go. So thank you all very much.